So Miriam, everything you missed so far is that we talked about which books we said were good. So I've heard that we said that the Princeton review is good. So if you want to get the Princeton review one, that's a good one. It has more of just like a cut and dry, like here's what you need to know, here's some examples to do, you can check your answers, and then here's 6 practice exams for you to like practice the test. So this one's a lot more practice and things like that. Then I was showing them this one. So that's the Princeton review. I heard that Barron's is really good. So Barron's AP Calculus AB review book. So I've heard that this one is really good if you like this one. I haven't looked it up too much, but if you find one, I think I found this one pretty cheap online, so you can find it pretty cheap, so that's a good thing about that one. The one that I personally like the best is the, what did I call it? Oh, Peterson's AP Calculus review book. This one I have a PDF of, and I really like it a lot. It does a really good job of explaining things, Miriam. So for example, like it gives a lot of good explanation. Where in the Princeton review, there's like 3 or 4 pages about continuity and limits, and in this book, there's like 100 pages about continuity and limits. So it does a really good job of going through the explanations. This one has fewer practice exams, so it's not as big, but I also like this one if this is one that you want to get. So we talked about that. We talked about how AP Central is a really good place to find out information about the AP tests. So you can come here for a course overview, what you're going to be tested on, things like that. Some exam tips, some practice exams and release test questions, things like that. What else do we want to talk about? The difference between AP Calculus and AB and BC is just that obviously you know. Oh, if you guys want donuts, by the way, you can have a donut. What are you looking for? I do, right here. I know, me too. So BC students cover everything that AB students do. They just go further. So they cover about 2 or 3 more chapters out of the book than AB students do. So that's just the difference between the two. It says, of the topics on the course description, which ones will appear on the test most? So the ones that you're going to want to look at most on the AP test are, of course it varies every year because they're allowed to test on everything. It says, but I asked my students to list the topics they saw most, and it says relative extrema, so mins and maxes, so we know how to find that using curve sketching. The relationships between derivatives of a function, so remember how we would go through like the first derivative and then the second derivative and the original function, and how are they related to each other. So for example, can you guys tell me if the first derivative has a 0, what does that mean about the original function? It had a turning point, exactly, yeah. So that's what they mean about the relationships. Or example, if the first derivative is above the x-axis, that means that the original function is increasing. Increasing, good. So that's what they mean about the relationships between functions. If you saw a graph or if they gave you a description of one of the derivatives, could you tell what it means about one of the other functions? There's a lot of free response on that. Yeah. So you need to know the difference, and we'll practice all of this, but just that's a thing that comes up a lot. The difference quotient, all right, that doesn't sound familiar probably in name, but the difference quotient is just it's like the long way of the derivative. Yeah, that's like a stem of it. It's just like, it's pretty much like this f of b minus f of a over b minus a, like the slope formula almost, how to find the slope. So it's a differential equation, so being able to find the derivatives of functions, but also we're going to go a little bit further into differential equations so you guys can figure that stuff out. Area between 2 curves we have not learned yet. We'll come up to that. The power series, elementary series, all that stuff at the end, that's all for BC, so you guys don't have to know that stuff. So really, there are 2 things we haven't, maybe 3 things, because we haven't learned a ton about differential equations yet, but really there's 1, 2, 3, 4, 5, 6, 7, 8 things, like 8 main things that are really heavily tested on the AP Calculus exam. And if you know those 8 things, you should be pretty good to go when we get there. Obviously for BC students, it'll be the power series, elementary series, we'll get to Taylor polynomials, radius of convergence, and integration by parts. So far the only one we've done together is integration by parts, but we'll get to the other ones eventually. All right, do you guys know how the test is designed, like what it's going to look like? All right, so there's 4 sections to the test. You know what it is? All right. It's split up into 2 sections, but each one is then split up into 2 sections from there. So each of which has a calculator active and a calculator inactive portion. So the first part of the test is the multiple choice. Well, they alternate. So section 1 has 45 multiple choice questions. That's it. You just have to answer 45 multiple choice questions. It takes 105 minutes. So you have about an hour and a half, a little bit more than an hour and a half actually, to take the first 45 questions.
I think like the first part is 28 questions without a calculator.
Yeah. Yeah, and I think that said that right there even. 17. So of that time, 55 minutes, so almost an hour, are spent on the 28 non-calculator questions. So you have like about a little less than 2 minutes per question to answer those questions. And then 50 minutes, so again, almost an hour, are spent on the 17 calculator active questions. So those ones you have about 3 minutes per question to do those. The second section has 6 free response questions. You have 6 free response questions, and you have 90 minutes to answer that second half. 3 of those free response questions allow you to use a calculator, and 3 don't allow you to use a calculator. So those ones are split pretty evenly. We're going to be, as we get closer to the AP exam, I'm going to have you guys do it like in class. I'm going to have you guys do some practice AP exams, and I'm going to time you just so that you guys are ready for that like time-driven aspect of it. So I just want to keep that in mind as we go forward. Should you guess on multiple choice questions? Absolutely. Don't ever, I hate when students leave questions blank. Seriously, the only test you should leave questions blank for, and that's only until like next year, is the SAT. As soon as they change the SAT, never ever leave a question blank on a test, ever. Yeah, always guess. Don't ever leave it blank. It drives me crazy when students leave a blank question, because you could just guess and maybe get it right. You don't lose anything, all right? This is wrong.
I think my worst fear is like circling the wrong one, and then like you circle the rest wrong. Cause like you know, you ever get
Oh,
that?
bubbling it in wrong?
Yeah,
Like in the wrong order?
Like you bubble instead of for one, you bubble 2, and you do the rest.
Hello. Yeah, I know, that would be bad. So you just have to be careful with that too. This is an old book. This isn't true anymore. You don't lose a fraction of a point for every multiple choice question you answer incorrectly. So you guys can guess away, right? You don't. That doesn't happen anymore. So yes. Should I have the unit circle? Remember I just said, yeah. Oh yes, the unit circle never dies. It will haunt you for your life. Should my calculator be in degrees or radians? You guys remember that one?
Radians. No.
Always radians. It should always be in radians. Always set it in radians. Unless the test says to do otherwise, but always set it in radians. So I'll remind you guys of that before we take the test. Here we go. This is what I told you guys, and there you go. It's proven. How many questions do I have to get right to get a 3? There's no set answer, but it's about 50%. If you can get about half of the questions right, you can get a 3.
What does it say on the top?
I know, it's a stupid. I told you, this guy's really sarcastic. I don't know, something about African rainforests and virulent monkeys. So this is what I was going to show you, but the PowerPoint wouldn't open, but I calculated the percentages, if I can remember off the top of my head. To get a 5, you have to get like a 74% or better, and these are approximates. They're not, because every year the AP test is curved a little differently, but through the patterns from years past, to get a 5, you need about a 74%, I would say. To get a 4, you needed like a 60%. To get a 3, you needed a 50% or better. And then obviously anything lower than that. I think a 2 was like a 33% or something. Which Ricky was saying yesterday in class that some schools accept 2s for credit on the AP test. He said he called some of the colleges he's applying it to and that they accepted 2s, right?
Down the street.
Right? I don't think any of the ones he said were in California, but maybe in other states. If you're applying out of state, you might want to. He said try and call the school you're applying to and see if they'll accept a 2 on the AP exam. Okay. This one, I've heard online, a lot of people say that the AP Calculus test is the most curved of all the AP tests, so it's actually the easiest one to pass, but only because calculus is a difficult subject to learn. So that's why they make the passing percentage so low, is that they don't want everybody to fail it. So is it difficult? Yeah, but is it hard to pass it? If you can get half the questions right, no. So I think most of you guys have averaged much better than 50% on most of your tests. So I would say that the thing we're going to prepare for the most is probably the free response questions, because each free response question is worth 9 points. All 6 of them together make a total of half of the test, so each one's worth 9 points.
And the timing is really crucial, because even
Yeah.
though Mr. Chang has used timings in every single quiz, I ran out of time.
Yeah, you'll run out of time too. So you have to kind of pace yourself so that you can answer as many questions as possible. Like answer all the easy ones first, obviously, and then go back and take more time on the more difficult ones. You can go online, find some good tests to help you prepare. I can put some of this stuff up online so you guys can see it. We'll look at how the free response questions are graded later. Should I show my work? Yeah, we'll talk about all that part, like nitty-gritty stuff later. So I just wanted to give you guys that overview of the test, just as a reminder for that. All right, let's get ready. So we're going to be doing some practice work. So if you guys have scratch paper, you can get out scratch paper. If not, I have some up here that you guys can grab. So let me get myself prepared while you guys get yourselves prepared. You are going to need a calculator, so get a calculator. If you don't have one, grab one behind the board. Good. And you're actually allowed to bring 2 to the test if you want to. I was reading that the other day. I thought it was pretty funny, yeah. They said you're allowed to bring up to 2 calculators to the test. Yeah, I think so. A scientific calculator is not approved? Oh, she can bring that one, yeah.
Can't bring this one.
Yeah, I think. There's only a few that you actually can't bring. The TI something like 89. Actually, even I think the TI 89, it's expensive, and if you know how to use it, it can pretty much help you answer a lot of the questions on the AP test. All right.
I think it's the same for the AP chemistry exam.
Really?
I think it's about if you get 50% of questions right.
Yeah, I know. It's kind of awesome.
My seniors are again gonna be
We are going to be working on AB stuff, unfortunately. But I did bring this. This is idiomas. Did she know that she left it here? Did she mean to leave it here? All right. So if you want to work on the AB stuff, you can. Because obviously, I was actually reading that the BC portion is 60% AB material and only 40% BC stuff.
I heard it's more AB.
More than 60? I heard 60, so I'm not sure. I might have read it wrong, but that's what I heard. So if you'd like to work through practice exams, because remember there's 2 BC practice exams in here, if you want to work through those. But I know Crystal said she would come at one point. I'm not sure what time she'll be here. Oh, she's not? Okay.
You were supposed to jump ahead, but she didn't.
Gotcha. So yeah, if you just want to work on this stuff with us, that works too. Just as a review.
One of the questions.
Gotcha. All right, so everybody works at different paces, so I want you guys to answer these 6 questions first. We'll go over the answers in just a minute. But I want you guys to try and answer as many of them as you can, and I'll give you guys a few minutes to do that. If you want to work together, please feel free. Huh? If you need to, sure. So for the first one, the limit as x approaches 2 from the negative side. Do you guys remember that that's the notation for that?
Yeah.
So it's approaching 2 from the negative side, not negative 2, but 2 from the negative side. So if I'm looking at 2 from the negative side, here's x equals 2. And if I'm looking at it from the negative side, I'm looking at it from this side. So what's happening to the graph of f as it goes towards 2? It's going to infinity. So the answer I would either accept, if this was multiple choice, it would either have does not exist or infinity. Both of those things are kind of synonymous with each other. The does not exist is the more accurate one, but sometimes they'll put on their infinity. There was one test question that we had that had both answer choices, and the AP test won't do that to you. So they will either put does not exist or infinity for something like that. So that first one is does not exist. For the second one, the limit as x approaches 3 from the positive side. So here's 3.
Because it's going to
1, 2, 3.
down.
Oh, I hate when it does that. Let me do it a different color.
It's really gross color.
1, 2, 3. All right, here's x equals 3. From the positive side, so that's coming in from this side. What's happening?
It's going to 1.
It's going to a number. What number is it going to?
Negative 1.
No, it's still good.
Let me get my... So it's coming in, getting closer and closer and closer. What number is it going to here?
Negative 1.
Negative 1. So the limit as it goes towards 3 from the positive side is negative 1. So this would be negative 1. For the third one, as x approaches 3 in general, so as it's getting closer to that point that I had here, what point is it going to here?
1.
Negative 1.
Sorry,
Still negative 1. Yeah, good. Negative 1. For the fourth one, the limit as x approaches 5 from the negative side, I'll let you guys figure the next 3 out. So try the next 3 on your own. And as long as it specifies left or right hand side, it's okay that it doesn't have both ends. Yeah.
So it's approaching from the negative side, so it's going this I mean,
There's a hole.
But is it getting
it's
closer to
getting
the number?
closer, so-
Okay, good. It's not continuous because it has a hole, but
But
does
it
the
has
limit
one.
exist?
Yes,
Yeah.
so it'd be
It's
one.
going if the limit exists if it's going towards a number. So 1, 2, 3, hold on, let me draw the line so we can all see what we're looking at together. 1, 2, 3, 4, 5. So we're looking at x equals 5, and I'm looking from the left-hand side. So the limit that this number is going to is right here. X equals 1.
And it worked for the going the positive. I mean, coming from the positive side, but
Okay, yeah. So let's look at it coming from the positive side. So this would be 1. What about as it comes from the positive side? I'm following it. What number is that going to?
It's going to -1.
Negative 1. And the last one is the limit as x approaches negative 1.
0.
Good morning. Good, that one would be 0. Just because it has a hole doesn't mean that the limit won't exist. The limit exists as long as it's going towards a number. If you want it to be continuous, you can't lift up your pencil. Remember, that's the one where you can't lift up your pencil. So that one can't have any holes, that one can't have any jumps, so on and so forth. And for it to be continuous, the left and right hand limits have to both go to the same thing.
So whether it's continuous or not, it doesn't really affect it if they have a limit.
Yeah, so when we first started learning about limits in calculus, limits were like super, super basic. Like there's not really much that has to happen in order for there to be a limit to exist. The only thing that has to happen is that it's going towards a number. Like your line is following along towards a number. That's all that has to happen. As long as it's not going to infinity, and as long as the only thing you have to look at is that the left and right hand limits are equal if it doesn't specify if it's plus or minus afterwards. So if it's the right hand limit or if it's the left hand limit, it's really easy for the limit to exist. The only thing that has to happen is that it can't go to infinity. If it doesn't specify left or right hand, like if there's no plus or minus here, then you have to have it not going to infinity, but you also have to have the left and right hand both equaling each other. But that's really all that it takes for a limit to exist, is that the graph is going towards the number, pretty much. All right.
It's like broken.
Say it again.
Like, there's like a gap.
Yeah, like on x equals 5.
Yeah.
As long as you specify left versus right hand limits, then you're okay. If they had a question up here that said, what's the limit as x goes to 5, but it didn't specify plus or minus left or right hand, then it wouldn't exist because the left and right hand aren't equal to each other. All right. Try these 3. Let me put them all up. There we go. Do you guys want me to do the first one with you? I'm going to put all these online, by the way, so that you guys don't have to, like, copy the pictures. Just because we haven't really done one like this in class before, so it might not seem totally making sense.
Would you use what's approaching, or as x approaches 2 on this side and gather the data from that, and then grab the x approaching 2 from the gx, and then add them together?
Yeah, and as long as the left-hand, right-hand limits are the same, then you're good. So here's essentially what we're talking about. So as long as the limit as x approaches 2, so let me highlight x equals 2. And then let me highlight x equals 2 over here. All right, so as long as the limits from both the left and right hand are equal to each other as x is approaching 2, when we add the two functions together, then we should be good. So on this first one, on f of x, what's the limit going to over here when you approach 2? -1. And then what's the limit going to over here as you approach -2? +1. Okay, good. But if you look at it from the left-hand side, the -1 plus +1, those are just going to add to 0. If you look at it from the right-hand side, the -1 plus +1, those are both going to add to 0. So yes, they're both going to 0. So the limit would exist on that one, and it would equal 0. All right, why don't you guys try 8 and 9? I'm sorry. For number 8, it says the limit is that it approaches 0. So as we're looking at 0, what's the limit for this one as it's approaching 0? 0. What's the limit for this one as it's approaching 0? 0, and you're multiplying. What's 0 times 0?
0.
So the limit for this one is 0.
I had that originally, but then isn't there like a lot where it's like
All right, and then for number 9, the limit is that's approaching -1. So if I look at this one from -1, oops. What's that one? Okay, it does not exist. And then if I look at this one from -1?
it's like 0.2.
Yeah, like 0.2, 0.3, something like that. So the fact that it does not exist on the top divided by 0.3 on the bottom says that it wouldn't exist. So this one does not exist. Good. On that first one, on the second one, I'm sorry, for g of x, if it had equaled 0, we might encounter an issue because you can't really divide something by a limit of 0. But the fact that it equals a number means that we're good to go on that one. All right, good. Perfect. Let's get some more.